Hi, I'm Ahmed Daud, and in this session, we will see a evaluation metric for the regression model. So, till now, we have started from the linear regression and we learned what exactly is linear regression. Then we moved on how we can train linear model. We have seen two methods theoretically gradient descent and normal equation. Then we moved on how we can implement in the form of code. We have seen a library scikit-learn from where we have used linear regression. We have done in the last session. So till now we have learned how we can train our model. Now the question is how we can evaluate our model, like our model is good or bad, how we can compare our models. Let's say we have multiple models and we can how we can evaluate that this model is good or bad or as compared to this model or this model. How we can come to know. Now today we will going to start the evaluation metrics for the regression models. Regression model, uh, regression models are for the continuous target variables or where we have continuous or target column or dependent column. Now, first of all, mean absolute error. So before moving towards the mean absolute error, I want to give an idea. The one evaluation metric, or you can say one metric we have learned till now. The metric was sum of squared error that we have used to train our model. Now we will also see in these sessions why we have used SSE in our training process, why we have not used another method or another metric. We also will see that. And keep in mind, this was just due to training process. This we have decided and we have used for the training purpose. Now, after the training part completed, we are going towards the testing part or prediction part. At that part, at the testing part or testing phase, we have to such a evaluation metric that can give us an idea which model is good or which is bad. Okay, so this error that SSE that we have used this metric uh, or this was for the training phase, and now we will see what we can use model for the testing phase, metrics for the testing phase. Okay, so first of all, mean absolute error. From the word mean absolute error, you got an idea in this error. Okay, I will start by one. Let's say, oh, 1 second. Okay, so error, we usually say error is equal actual minus prediction. We usually call it as error. How much our prediction is far away from the actual value. We usually call it as error. Now, absolute means we are taking absolute. In sum of squared error, we are taking square of that. Now, here we are taking absolute. Okay, we are taking absolute instead of taking square. So here is y minus y gap. Okay, we will take absolute instead of taking square. We will also see what's the reason why we are taking absolute. Okay, so second, mean. Mean is that in the sum of squared error, we are adding all the squared errors. Okay, that's why we said sum of squared error. Here we are saying mean absolute error. Here we will add all the absolute errors and we will take a mean. Just take a mean by dividing the number of points. Like here, we will add all the points here. Here you can say we will add all the absolute errors. Then we will divide by n to take a mean. N is it here in that case, n is actually equal to 5 in our case. Okay. In this case, in the case of that data set. Okay. In this way, we can calculate that. So here, let's say we have this one. This is our original actual value against the area 30 square feet. We have 5.65. But our prediction is showing us that uh, prediction is 5.8. Now the difference between prediction and the our actual value is minus 0.15. Okay, this one. Now this one minus 0.15. Now here when we will take absolute, so taking absolute, you know about that. Taking absolute is just to neutralize the sign. So here we have neutralized the sign. Now we have error in the second point, in this case 0.15. In this case, in this way we can calculate for all the 5 points the absolute errors, then we can add all the absolute errors and then divide by number of points. Okay, so in this way we know this formula how it works, and we can use that formula for the evaluation of the model. Now we will see some of the advantages and disadvantages of that model. So first of all, the advantage is robust to outliers as compared to MSc and RMSc. We will see how it is robust to outlier. The reason is that in sum of squared error we are taking square. Okay, for now, I will tell you what is mean square error. Okay. So in sum of squared error, we are, let's say here yi minus y cap. We are taking square. Here is I is equal to 1 to n. And okay, so this is our sum of squared error. Now mean square error is simple. Sum of squared error divided by number of points here. So this is mean square error. Okay. Now how our m this MAE this MAE is robust as compared to MSc. The reason is that in MSc we are taking square. If there is some outlier, okay, there is a bigger error. When we will take a square, it will become more bigger. Okay, so a large error we will generate, or we will generate a square term. That's why it can enhance your overall sum. Okay, so that's why you can say your MSc, due to nature of squaring the errors, is not robust to outlier, but instead of uh, MSc, MAE is robust to outlier as compared to MSc. MAE is robust to outlier due to nature of taking absolute. It takes absolute value. Okay, it don't take the squares to neutralize the signs. Okay, it takes the absolute. Now we got an idea why it is robust to outlier. Now we will see another advantage. Another advantage is explained in the context of variable. What exactly it means? It means, let's say your MAE here. Let's say you got your MAE for that model. Let's say 5.6. What it explains there, it means it has the same unit as our data have. Like here, if I will show you, our data has a unit price in lakhs. Okay, so same unit we will have here. And so MA is 5.6 means that our model is giving a absolute error, mean absolute error of 5.6 lakh. Okay, in this way you can, if you are going to compare multiple models, you can say this model is giving 5 lakh error of 5 lakh, this model is giving a 10 lakh error, this model is giving a 2 lakh error, so this model is giving 2 lakh error, as it is less than as compared to other models errors. So it can be good. Okay, so here the context of explanation is the same as the data set we have. Okay, the same unit we have here. So it's another advantage that we don't have in the case of mean square error. We will see in the next session. And you can also get an idea, because of squaring term our units also become in the form of square. So but in MAE case, we have the unit as the same we have in the target variable. Now these two advantages. Now the biggest disadvantage of mean absolute error, and you also have in your mind that if it is so good, so why we don't have used this MAE during our training process? Why we have used sum of squared error, or you can say sum of squared error is same as the mean square error. Just we, in case of mean square error, you are taking here in the case of you are just taking the average, but overall sum, if you will keep the sum, then it is sum of squared error. If you will take average, then it is mean square error. Okay, so you have an idea that why we have not used mean absolute error during the training process. The biggest reason is that because mean absolute error is taking absolute, so when we have to in the training process, we have to take some derivatives, differentiation we have to take. But absolute, due to absolute nature of the function, it is not appropriate because of differential issue. Okay, we cannot take a direct derivative, or we cannot we have a differentiation issues when we have absolute function. Okay, differentiation issues for the absolute functions. Okay, for the absolute functions. So as this MAE is have absolute function, so it is difficult to take a derivative of that function. So in training process we have to take a derivatives, but MA, in case of MAE we cannot do that. So that's why it's not appropriate for as a loss function. You can say loss function, we usually say the function that we usually use for during our training process as a error function. Okay, so MAE is not appropriate, you can say, for the training purpose of regression model or for linear regression. Okay. So you have seen this mean absolute error. It has two advantages, that your explanation is same. Explanation is in the context of the target variable that you have. There is no change in the difference or no different units. Okay, you can explain very well by using MAE, and it is also robust to outliers. So now we will see how we can implement this mean absolute error by using in the form of code. Okay, we will implement that. So here you can see we have this one. If I will make zoom in. Okay, so here we in the last session we have seen this area price, and this one is a predicted price. Now we want to see how much the difference between actual price and the predicted price in the form of some error. Okay, you see how far away our prediction from our actual values. So first, evaluation metric, mean absolute error that we are learning here. So first, I will implement that by manually, that we have learned so far by using a formula, actual minus prediction, taking absolute, then sum all the value absolute errors, and then divide by number of samples. Okay. Here this is predicted by price. Now I have added another column in which I am subtracting actual, which is price, minus predicted price, y minus y predicted. Here we have some of the positive values, some of negative values. If I will directly add these values, you can get an idea. It will neutralize, or it can be fall into some uh, it can be led to some missing of the information or missing of the error. Actually we are interested in the how far our error, our actual values from the predicted values, or predicted values from our actual values. We are not interested in the sign, either our prediction is on this side of actual or on this side of actual. Okay, we are not interested in that. We are interested in the magnitude of the error. So that's why we are making neutralize these signs. So I am taking here absolute. Now we have another column which is same as this one, just without the signs. Now I will take sum of that. Here the sum is 0.56. You can say this is sum of absolute errors. Okay. This is now sum of squared errors. This is sum of absolute errors. Now to make a average, to make a mean absolute error, I will just divide this 0.56 by 5, as we have 5 number of points here. So we have 0.11 absolute error. Mean absolute error for this model is 0.11 for this model. Okay, we have 0.11 mean absolute error. What it actually means, as the unit of target variable is in lakhs, you can multiply the lakh with 0.11 and you will get an answer that 11,000 the difference. Okay, your error is mean absolute error is 11,000. Okay, on average you can say your prediction, your actual prices of the houses and your prediction of the house prediction prices or predicted prices of the houses have a difference of 11,000. Okay, you can say that if some model has bigger than, then you can say the model that has bigger error, it is bad, and the model which has less error than that, we can say that model will be good as compared to this model. You can compare the models. So in the same way, I have done this manually or one by one, so you can get an idea about the formula. You can directly use by the sklearn dot matrix import mean absolute error. Here you will pass in this mean absolute error predicted price, and this one is your actual price, this one is predicted price, as it is in the two-dimensional array. So I have just make it one dimensional by using flatten function. Now here I am passing here mean absolute error function. Here this is actual prices, these are the predicted prices, and it has given me 0.11, same as we have calculated by ourselves. Now, when you will multiply this by 1 lakh, because our target column has a unit of 1 lakh, here you can see, okay, it is in the form of lakh, 5.5 lakhs, 5.65 lakh. So I have just converted it to, you can say that the difference, the mean absolute error is 0.11 lakh, or in other words, you can say 11,246. Okay, 11,246. If the this is these are the dollars, the price is in the dollars, then you can say your actual values from the actual value, your prediction on average, the difference in your actual and predictions is 11,246 dollars. Okay, so in this way, you can explain your metric. Okay, you can explain your model for and you can also use this mean absolute error for the evaluation metric. But keep in mind, due to nature of absolute function, we cannot use this function as a training purpose. Okay, so I hope you got an idea. In the next session, we will explore some other metric functions. So for now, thank you.